Hi everyone, this is going to be the first video for week 5. As I mentioned before, there's not a lot of material for week 5, so there's probably going to be 2 to 3 videos in total. We're going to talk about a couple of functions that you've seen in 103, and that's the reason I'm sort of isolated this topic for the end, because it's not related to trig functions. Although there is a concept of inverse that we will talk about here. Yeah, and these pair of functions and inverses that you've seen before are called exponential and logarithmic functions. So one way to motivate that is to start by thinking of polynomial functions, namely functions like x, x squared, x cubed. So what happens here is you plug in values for x, right? When x is 1, it's 1. When x is 2, it's 2, 3, so on. For x squared, when you plug in 1, you get 1 squared, 2 squared. And then again 1 cubed, 2 cubed, so on, till for n. So that's one way to look at the function. But we can say that instead of looking at it, left to right, what if I look at it top to bottom? So let's say I want a function which gives me these values for different inputs. So in this case, the input would be like 1, 2, 3. Here the input would be 1, 2, 3. So what remains constant in this case is this number. It's always 4, but it's raised to different powers. It's raised to the power 1, 2, 3, 4, 5. Again, over here, the number 6 is fixed, and what changes is the exponent. So what happens is, then the variable is on the exponent. And this is called an exponential function. Okay, so we can sort of see from polynomial functions that we get exponential functions by thinking of how we can go column-wise instead of row-wise. So here's the formal definition. Any function of this form, b to the x, for b greater than 0 and b not equal to 1 is an exponential function, and b is called the base. Let's look at an example. Y equals 2x. So let's take different values of x. So when x is 0, I get 2 to the power 0, which is 1. When x is 1, it's 2 to the power 1, so it's 2. When x is 2, it's 2 squared, which is 4. So you can see the values keep on increasing. What if it's negative? Then you get 2 to the negative 1, which you know by exponential laws of exponent, or just writing notation, just means 1 over 2. So negative 2 would mean 1 over 2 squared, which is 1/4. So if your input is positive and increasing, then the output increases, right? So as x increases, y increases, and as x decreases, y decreases. But y can never be negative. It just becomes smaller and smaller. So if I were to plot this, at 0 I have 1. At 1 I have 2, at 2 I have 4, but then it becomes 1/2, 1/4, 1/8. So you have this function. One way to remember this is that you can also call it a J-curve, to say that kind of looks like a slanted J for exponential. And because any number to the power 0 is 1, it's always going to go through this point 0, 1. Let's look at this another example. We're going to plot this in two different ways. First, by taking various values of x. Now notice that because the exponent is negative, The 0 part doesn't change, right? Because 2 to the power negative 0 is still 2 to the power 0 is still 1. But when the inputs are now positive, it's going to be 2 to the power negative 1 becomes 1/2, and 2 to the power negative 2 becomes 1/4. We got that from here. And when the exponent is negative, or when x is negative, the exponent is positive. So it's going to be exactly like this table, except around 0, you flip it, right? Whatever's, when your input was positive, what you got as output here is what you would get as output when your input is negative. So in that case, when you look at the values, once again, you have 0, 1, but now as x increases, y decreases, right? Because you can see, as x becomes more, y becomes smaller, so it's dying out. And as x decreases, y increases. X decreases in the sense, x becomes more and more negative, then y increases. So what happened here is the quadrant 1 part flipped over to quadrant 2 and the quadrant 2 part flipped over to quadrant 1. So they interchanged. Another way to view this graph is by thinking of transformation. So I can go from y equals 2x to y equals 2 to the negative x by replacing x by negative x. What that does is reflection about y-axis. Why? Because you're saying that whatever input x, the input becomes its negative. Alright, so if the input was positive, it's going to give me, it's going to be negative now. And if the input was negative, it's going to be positive. And so, based on transformations, I start with 2 to the x, and then I go to 2 to the negative x. Okay, this never touches the x-axis. That's a mistake there, because it's a rough sketch. So anyways, this is something you've seen in 135, is just general graph transformations. So once you have that, you can just plot these exponential functions, right? So this transformation, what it does, that's the general shape, and this point is important, 0, 1. Now this transformation is subtracting from the, it's not changing x, it's changing y. You're shifting all the outputs down by 3. So if you shift it down by 3, here the output was 1, and you're going to get negative 2. But the shape doesn't change, right? And there's going to be some value of x which makes the y 0. So it's going to go like that. And this value, we'll see once we go over logarithms that you can find that value. But this point is going to be 0, negative 2. Similarly, the 10 doesn't really affect it because 10 to the power 0 is still 1. In this case, you're changing x to x minus 1, right? X to x minus 1 means you move right by 1. So it's going to look something like that, and so when x is 0, now you have 10 to the negative 1, so this is going to be 1/10 actually, right? But when x is 1, it's going to be 1, 1, because then it's going to be 1 minus 1, 0, and 10 to the power 0 is 1. The rest are kind of similar. One interesting one here, if you have 1 over 5, you can always rewrite this as 5 to the negative x. So you would go from 5 to the x, to 5 to the negative x, to negative 5 to the x, to 3 minus 5 to the negative x. Okay, that's just how you do transformations. 5 to the x looks like that, and that point is 0, 1. And we've seen that changing x to negative x is reflection along the y-axis. So that's what we're going to get, still 0, 1. Now changing y to negative y is reflection along the x-axis. So that's going to make this all of this negative. So this will be 0, negative 1. And now I'm adding 3 to the output, meaning I'm going to move this 3 up. If I move this 3 up, the negative 1 becomes 2. And I still have this shape, so it's 0, 2. And you can verify when x is 0, this is 5 to the power 0, which is 1, and 3 minus 1 is 2. So you end up with this plot. So these are just transformations that sort of revisiting them from 135. Okay, I'm going to stop this video here, and then the second half of exponential functions, I'm going to cover that in the second video.